Units and measurements, it's a very interesting topic. Actually, you are going to miss a lot of things in both physics and chemistry if you don't understand units and measurements. So the first thing that we want to talk about in units and measurement is, you can see even from the word itself, you have got units and measurements. Okay, so let's start with units. When you are dealing with units, you know, when you are writing a quantity, you are going to see a quantity is going to have, let's say for example I'm talking about money, right? Is going, let's say this is a 10, we are going to put a k there. This is representing what quantity we are talking about. The quarter there is representing money or dollar or something like that. That's the same way with things like length. So for length, for example, I can say 5 meters. This 5 is representing the size. The meter, that is going to be the unit. So when we start with a 1, I'm going to put a 1 here, and on top we are going to be writing numbers with positive powers. So we are going to have 10 to the power 1, 10 to the power 2, 10 to the power 3, and then 10 to the power 6, 10 to the power 9. We can continue going like that up to whatever that we can reach, maybe 10 to the power anything. So what we are seeing is these which are on top here, the powers up. Can you see there's 1, 2, and then the others are multiples of 3. In other words, the 3 can go into them. So 10 to the power 1 is known as a deca, and then 10 to the power 2, that is known as an hectare or hecto. Now for these guys you use capital letters. This is going to be capital T, this is capital H. 10 to the power 3 is known as a kilo, so we are going to use capital K. 10 to the power 6, that's actually a million, so that is a mega, and you use capital M. 10 to the power 9 is a billion, so that's giga, and then you use capital G. You also have 10 to the power 12, which is a tera. Now when we are going down, we are going to be having negative powers. 10 to the power negative 1, 10 to the power negative 2. We'll start again moving in multiples of 3. 10 to the power negative 3, 10 to the power negative 6, 10 to the power negative 9. You can also say 10 to the power negative 12. So 10 to the power negative 1 is known as a deci, not deca but deci. For example, decimeter. So you use the small letters for these ones which are down. And then we have got 10 to the power negative 2, which is a cent, like a centimeter. So use small letter C. 10 to the power negative 3, that is a micro. So the symbol we use there is mu. It looks like a U. That's mu. 10 to the power negative 6, actually 10 to the power, okay, 10 to the power negative 6 is what we call a micro. So let me remove this. The 10 to the power negative 3 is a milli, like millimeter, right? You use a small m. Micro is to the power 6. We have got 10 to the power negative 9, which is known as a pico. Actually, this is 9 is nano. Pico is 12. So this is going to be small n, this is small p. So what's the importance of you understanding these things? Because we're not just writing them for fun here. you are going to see a lot of questions. For you to be able to answer them, you need to convert between units. Let's say, for example, they have given you 20 kilometers. They say change these 20 kilometers to meters. So the way we are going to do for you to convert, just write this 20, right? 20 kilometer. You are going to multiply. Can you see that the kilo, we call it a prefix? So all these things I've written here are prefixes. They come in front of a unit. The actual unit is a meter. I can put a kilo in front. That is just representing the prefix. It's meaning 1,000. So when I want to convert a kilometer to a meter, what I'm going to do is I'm going to write like this. So can you see there is a kilometer and this is on top. So what you do is write the kilometer down. Where do we want to go? We want to go to a meter. So remember, this one here is the one that is representing the actual unit. All right, the actual unit. So if it's a meter, it's representing a meter. If it is a gram, it is representing a gram. The actual unit without the prefix. So you ask now yourself, between a meter and a kilometer, which one is bigger? So things, as you go up, units become bigger. As you go down, units become smaller. For example, deci is bigger than a milli because deci is on top. So since kilo is on top here and then a meter is a standard, is going to be down here, so kilo is bigger. So in front of a bigger number, put a 1 there. And then what does kilo mean? Kilo means 10 to the power 3 or 1,000. So I'm going to put 10 to the power 3 there. So when you multiply, you are going to see this kilo is going to cancel with a kilo. And then the answer is going to be 20 times 10,000, which is basically 20 times 1,000, sorry. That is going to be 20 times 10 to the power 3 meters. You can also write it as 20,000. So like this, you have converted your unit. It is as easy as that. Let's do another one. Let's say, for example, you've been given 40, let's say, micrometers. They say convert this one to meters. Or it's not just meters. Let me use something else. Let's say it's 40 microgram. They say convert it to grams. So the way you are going to do is simply write the 40 microgram and then multiply. Again, because I've got a microgram on top, I'm going to put a microgram down. And then I'm going to put a gram on top. Now, can you see that micro is down, a gram is on top? Again, ask yourself, so gram, because G itself doesn't have any prefix, meaning that it's a reference point. So ask yourself, between a gram and a microgram, which one is bigger? A gram is big because a micro is down here. So what are we going to do in that case? In front of a gram, put a 1. So if you just know which one is bigger, that's all. And then come on micro. What does micro mean? Micro means 10 to the power negative 6. So I'm going to write 10 to the power 6. I've not put a negative number there. I've not put a negative 6. So the thing is that as long as you have put a 1 in front of the bigger unit, it doesn't matter whether you are talking about the terms which have got positive powers or the terms that have got negative powers. Just use positive power as long as you have put a 1 in front of the bigger unit. If you understand that, it will save you from unnecessary pressure and you are going to be very fast when it comes to making conversions in units. Okay, so therefore this is going to give you, you can see microgram will cancel with microgram. So we are going to now multiply 40 by 1 divided by 10 to the power 6. So that is going to be 40 times. Remember from your indices in high school, when you have got a number that is down and it has got a power, you can take it on top and the power becomes negative. Remember from indices? So yeah, so this is the conversion. 40 times 10 to the power negative 6 grams. Is there any question? Yes, please. So this one is just representing the conversion unit. For example, we are simply saying that in 1 gram you have got it 10 to the power 6 micrograms. That's the meaning of this thing here. It's just a conversion factor. Is that okay? Okay, good. Is there another question? Okay, great. Please, in case you have got a question, don't feel shy. Be very free to ask. Let's do another conversion. Let's say, for example, they've told us that convert 20, let's say, nanometers to kilometers. Now, can you see for this kind of question, we are coming from nano, which is on the negatives. We are going to kilo, which is on the positives. So you can't go direct like this. Of course, you can, but if you don't want to be confused, the first thing that you do is convert first the nano to the standard. After you convert from this to the standard, and then you can now convert to a kilo. If you do this, trust me, these conversions will be the simplest thing for you. So we're going to get 20 nanometers. We are going to multiply. Since I've got a nanometer on top, I'm going to put a nanometer down. I first want to go to a meter, which you can see there is no prefix. There is no any letter in front here. So there is no prefix. And in comparison to a nanometer, a meter is bigger because nano is on the negative sides. So therefore, in front of a meter, I'm going to put 1. But remember, what does nano mean? 10 to the power negative 9. But I said that as long as you have put a 1 in front of the bigger number, the bigger unit, forget about the negative, just write 10 to the power 9. So this nanometer will cancel with the nanometer. The answer will remain in meters. And then now we want to convert from meters to kilometers. Again, I'm going to multiply. So I've got a meter on top. I'm going to put a meter down so that they can cancel out. And then I'm going to where? I'm going to kilometer. So now ask yourself again, between a kilometer and a meter, which one is bigger? Here, a kilo is bigger because it's on top. So I'm going to put a 1 in front of a kilo. And then, remember, what does kilo mean? 10 to the power 3. So in front of a meter, I'm going to put 10 to the power 3. So I just put a 1 in front of a bigger unit, and then what the k means is 10 to the power 3. That's what I put in front of a meter. Again, this will cancel with a meter. So my final answer is now in kilometers. So this you just punch on a calculator. This is going to be 20. There's no need even to punch on a calculator. You know from indices, when you're multiplying numbers of the same base, you add the powers. So 10 to the power 9 times 10 to the power 3, just add the powers, which is 9 plus 3, and that will give you a 12. But because this guy is in the denominator, 10 to the power 12, when you take it on top, it becomes 10 to the power negative 12, and that is going to be in meters. So this you have converted from nanometers to kilometers. Sorry, this is kilometers, not meters, to kilometers. Is there anyone that is left out? Anyone that is behind? Where exactly? Okay, so let me give you again another example. Let's say you have got 4 kilometers. They have said convert this guy to, let's say, micrometers. So what do you do for you to make that conversion? First get this 4 kilometer, multiply. I've got a kilo on top. I'm going to put a kilometer down, and then I'm going to have a meter on top. Between a meter and a kilometer, which one is bigger? Anyone that can help there? Yes. Thank you. Kilo is bigger, right? So we're going to put a 1 in front of the kilo. But remember, kilo means 10 to the power 3. So I'm going to get that 10 to the power 3 and put it on top. So the kilo has cancelled with the kilo. So we have remained in meters. But we want to go to micro. Again, I'm going to multiply. I've got a meter on top. I'm going to put a meter down so that it can cancel. And then I'm going to have a micrometer on top. And then between a micrometer and a meter, which one is bigger? A meter is big. Good. So I'm going to put again a 1 in front of a meter. But remember, the meaning of micro is 10 to the power negative 6. Since I put a 1 in front of a meter, so I'm just going to put 10 to the power positive 6. So this meter again is going to cancel with this meter. So what we have remained with is now 4 times 10 to the power 3 times 10 to the power 6. And 10 to the power 3 times 10 to the power 6, same basis, just add the powers. So it's going to be 10 to the power 9. And the answer is now in micrometers. So this is how you make a conversion. Does this make sense? Good. All right. Please be free if you have not gotten it. Let's do some other conversions that you need to know. How about if you're talking about conversions in time? Let's say they've asked you to convert 4 hours. The mic can be off, please, so that you can switch it on in case you have got a question. Okay. So we have got 4 hours. You want to convert it to seconds. Just the way we've been doing with the others. So what you just do is get the 4 hours, multiply. You can go direct, but let's not move too quick. We have got hour on top, so we're going to put hours down. We can first go to minutes, right? And we know a hour is bigger than minute, so put a 1 in front of the hour. Do you know that in 1 hour we've got 60 minutes, so put a 60 there. So these hours will cancel with the hours there. Our answer is now in minutes. Again, multiply. We have got a minute on top, put a minute down. And then we want to go to seconds. A minute we know is bigger than a second, so put a 1 in front of a minute. In a minute we have got 60 seconds, so put a 60 on top. So this again will cancel with this. So therefore the answer will now be 4. 60 times 60 is 3600. So this is going to be it. You just punch on a calculator and the answer will be in seconds. That is how you convert it. Very easy, very direct, nothing complex. Hope that is okay. Now, some things that become a bit interesting is where they start putting, let's say you're talking about area or volume. Say they say convert to meters squared. You want to convert this to, let's say, centimeters squared. How can you do that? The thing is, just get the 2, right? This is in meters squared. Multiply. Since I've got a meter on top, I want to put a meter down. And then I want to go to where? To a centimeter. Remember, a meter is bigger than a centimeter. So in front of a meter, just put a 1. And then, as we said earlier, cent means 10 to the power 2. That's 100. But as you can see, this is a meter. This is a meter squared. Those things are not adding up. So what you do is get now the entire of this thing, raise it to the power 2, and the entire of this thing, raise it to the power 2. Why are we doing so? We want to balance the units. So this will basically give you 2 meters squared times 10 to the power 2 squared. That will give you 10 to the power 4. And then centimeter will also get the squared. Remember, when you have an index raised to another index, just multiply the two indices. And then in the denominator, 1 squared is just a 1. and then the meter will also carry the square. So at this point, this meter squared can cancel the meter squared, and so the answer will simply be 2 times 10 to the power 4 centimeters squared. So this is how we make the conversion here. Hope that's okay. We can have another conversion so that you just understand how to be able to do it. Let's say, for example, you're talking about, what can I use? Velocity. You know, velocity is given in the SI unit. The standard unit is meters per second. So let's say, for example, you have got say you have got 5 say you have got 5 kilometers per hour, and they've told us to say convert this one to meters per second. Remember, this is the SI unit for what? For velocity. So how do you do that? The SI unit for velocity is meters per second. So just get the 5, write it like this: kilometer over hour, and then multiply. I'll first convert the hour to second, or I can start with a kilometer, I convert to meter. So the kilo on top, I'm going to put a kilo down. I want to convert it to meters. In one, so kilo is bigger, so I'll put a 1, and then on top where there's a meter, put 10 to the power 3. So you can see the kilo will cancel with the kilo. So the answer is now in meter per hour, but I want to go to meter per second. So again, I'm going to multiply. I'll now convert the hour to seconds. Hour, since hour is down, I'm going to put it on top, and then I can go direct to second. Okay, in 1 hour we have got 3600 seconds, like 60 times 60. So this hour will cancel with this hour. So therefore, our answer is now in meters per seconds. So this is going to be 5 times 10 to the power 3 is 1000. In the denominator we have got 3600. Remember, on top we have got meter. In the denominator we have got a second, meter per second. Two zeros can cancel with these two zeros, and then you can simply say 5 times 10, that's a 50. 50 over 36, you punch in the calculator, that will give you the actual number. Is there anyone that is left out? Anyone that is left out? Okay, good. Please be free if you are not good. Yes, please. Yes, let's do an example of conversion of acceleration. Let's say, for example, you have got 2 kilometers. Remember, acceleration is velocity over the square of time. So let's write it like this: 2 meter per second squared, and you want to convert, let's say, to kilometer per hour squared. Actually, in your physics, if they give you acceleration in this unit, you can't work with it, because that's not the SI unit. You have to convert to meters per second squared. That's the only way you work with it. If you use a number that is in kilometers per hour squared, you'll get a wrong answer. So that's why I need to know the conversion. So what do we do in this case? We're going to write 2 meter, I'll write like this, over second squared. Okay, you can see the way I've put the second squared down. I'll first convert a meter to kilometer. I'm going to put a meter down, and then I'll put a kilometer on top. Why? Because the meter was on top, so I need to put it down so that I can cancel. Kilo is bigger than a meter, so I'm going to put a 1 in front of a kilo. And then remember, kilo means 10 to the power 3. So this will cancel with this. We have now remained in kilometers per second squared, but we want to go into hour squared. Again, multiply. We have got a second squared down. We are going to put a second on top. We want to go to hour. Now we know that in 1 hour we have got 3600 seconds. But wait, We are dealing with second squared, not second. So what are we going to do? Get the entire of this, square it, and also the entire of what is in the denominator, square it, so that what is going to happen is that the 3600 is going to carry a square, the second will carry a square, the one will carry a square, the hour will carry a square. Now we are dealing with the right units. So the second squared will cancel with the second squared, and therefore this is going to give us 2 times 3600 squared. Remember, we also have a kilometer. And then in the denominator, what do we have? We have got 10 to the power 3. 1 squared is just a 1. And then we also have a hour squared. Instead of saying over hour squared, over is the same as pay, hour squared. So we have converted. Simply get this quantity, punch it on the calculator, and then that will be it. Actually, we can just do it easily here without even a calculator. Does that make sense? Great. So this is how you make conversions. So there's something that we call dimension analysis. In dimension analysis, we are just trying to see what are the quantities that makes up a dimension. Now, when you're talking about quantities, you have got a primary quantity and a secondary quantity. The basic quantities, or the primary quantities that we have, they are 7. If you remember from high school, number 1 is length. The SI unit for length is meters. Anyone that knows another primary quantity? We have got also time. The SI unit for time is second. Anything else? You, do we remember the 7? Very good. Mass also. The SI unit being a what? So this depends. In chemistry, the SI unit for mass we are going to be using is a gram. In physics, the SI unit is a kg. Because chemistry, we don't deal with big things, we deal with the small things. That's why we use grams. What is the any other primary quantity that we remember? So we have got the 3 remaining 4. Remember temperature? Temperature, what is the SI unit? Kelvin. Very good. And then the next primary quantity? Very good. Distance or length. But length is there, right? Length is the same as distance. Do you remember amount of substance? Amount of substance. What is the SI union? Yes, the more. Anything else? Very good. Luminous intensity. Okay. What is the SI unit? Candela. Okay. CD. And then what is the last quantity? Yes, very good. So we have got current. And then what is the SI unit? Amps, isn't it? Or ampere. So these are known as basic quantities. When you combine any one of these, you are going to get what we call a derived quantity. For example, velocity is a derived quantity. Okay? Velocity is a derived quantity. In case the mic you've forgotten to switch it off, please switch it off, and then you can open it when you have got a question. Right? Boston, you can try to switch off the mic. Okay. So now, let's talk about derived quantities. Derived quantities, sure, no problem. Derived quantities, let's say for example velocity. Now velocity is actually given by distance over time. So you can now find the SI unit for velocity. Since the SI unit for distance is meter, in the denominator we have got time, the SI unit for time is second. That gives you the SI unit for velocity. Okay, like that. Same way with acceleration. Acceleration is given by, anyone that knows how we find acceleration? It is velocity, isn't it? Excellent. Velocity divided by time, or we can say distance divided by time times time. So distance is in meters, and then we have got two times there, so it will be second times second, which will be second squared. Of course, if we want to be specific, velocity is not even distance over time, but displacement over time. But we'll talk about that. We are going to understand the difference between velocity and displacement and distance when we talk about uh, vectors and scalars. Another thing I want to talk about is, let's say, force. Now, force has got a lot of formulas. For example, force is actually according to, if you look at the Newton's laws of motion, there are of course a lot. You are going to find that force is mass times acceleration. So you can find the unit for force by using this formula. That will give you mass. The SI unit for mass is kg. The SI unit for acceleration is meter per second squared. So therefore, the SI unit for force becomes kg meter second squared. If you remember, you also learned that the SI unit for force is a newton. This tells you that 1 newton is actually equal to 1 kg meter per second squared. This is how they can bring a multiple choice question. They'll ask you 1 newton is equal to, they start putting 1 kg meter per second squared, 1 kg meter second squared. They'll put different things. This is how the unit comes about. I can give you another one, a unit for pressure. Now you know that pressure is given by force over area. And we have just said that force is mass times acceleration, and then the area is, I can still put A there, which is the area. And mass, we have said this in kg. Acceleration is meter per second squared. And then in the denominator we have got area. Area is also a derived quantity. It's actually given by length times another length. It's length times length. So it is meter times meter, which is a meter squared. So what you are going to see is that this 1 meter will cancel with that meter that is on top. So we have remained with a meter in the denominator. So this is going to be kg. If we say per second squared, it means that this second is in the denominator. So in other words, in the denominator we are now going to have a meter and a second squared. This is the unit for pressure. And you remember that pressure is also given in pascals. This tells you that 1 pascal is actually equal to 1 kg per meter second squared. The other way they can write this is they'll write 1 pascal is equal to 1 kg. If I don't want to write per, this is slash, I'll simply write meter, write a power negative 1, and then second, write a power negative 2. These negatives just tells you that the meter and the second are actually supposed to be in the denominator. So if you see this in the exam or you see this, it's all the same. Is this okay? There is this exam question. Which of the following is equal to a unit of pressure, which is a pascal? Kg meter second, kg meter per second, kg per meter second squared, newton, per meter second squared. Which one is the answer? So you've seen how questions come, right? So we've written it here. That's kg per meter second squared. So the answer is this one. Okay? So that's what you need to be aware that those are some things they can ask you. Another thing you need to understand when it comes to units and measurements is how to round off and find significant figures. It's very important. It seems simple. Remember just the first test one. Some questions came on significant figures, and we said that we know these things from high school. Anyway, there are some rules you need to know that you might not have known from high school. So let's first talk about how to find significant figures. So when number one, if you have got a number like 23, where you've got number from 1 up to 9, those numbers are significant. So if I've got 2, 3, 2, 4, these are four numbers, so I've got four significant figures. It's as easy as that. But the problem some good rules start coming in when you're having some zeros. If I've got 43 0 0 0, can you see this number? This number has got 4 and 3, and then the zeros are coming after the numbers. These zeros are not significant, so this number only has got two significant figures. But if I've got a number like this, 43 0 0 0, and then I put a point, the zeros that are in front of a point, as long as the numbers that will be in front of those zeros are not zeros, those zeros are significant. So this number has got five significant figures. What's the difference? The difference is a point. Okay, as simple as that. But if I've got numbers like this, let's say 0.001, all the zeros that are behind a number, they are not significant. So this number has got only one significant figure. But if I had 0.0000100, the zeros that are after a decimal number are significant. So this number has got three significant figures. If you have got 0.10001, all the zeros between two numbers are significant. So this number is going to have 1 2 3 4 5. So it has got five significant figures. The same if I had written it as 0.100010000, even these zeros which are coming after, they are going to be significant. It's only for a decimal number, it's only the zeros that are in front which are not significant. So this one is going to have 1 2 3 4 5 6 7 8, 8 significant figures. Does this make sense? Okay, good. Now that you have understood significant figures, you need now to understand how do you round off these numbers to a certain number of significant figures. Let's say I've got 4 5 6 0 0. This number has got three significant figures. If they say round it off to two significant figures, what you are counting is number 1, number 2. So you just want it to have those two significant figures. So what you do is look at the number that comes thereafter. If it is above 5, remove a 1 from it and put on the 5. So this is going to be 46. The rest of the numbers here, make them zeros. Please don't leave them out, because you are trying to maintain the way the number is. This number is actually in terms of thousands. So if you just write 46, this is in tens. So you have not maintained the actual number. So put all the numbers that were there become zero. So this is 46 for 60,000. If you have got 4, let's say 9 9 9 9, they say round off this number to three significant figures. You are going to count 1 2 3. So from a 9 you are going to remove a 1, you put on this 9, but this 9 will become a 10. So again, still remove a 1 from it, put on this 9, it will again become a 10. Again, still remove a 1 from it, put there, it becomes a 5. So that will become a 5. The rest will be zeros. 0, 0, 0, 0, since they were 3, they were 4. So I've rounded off to 3 significant figures. Let's say this same number, they said round it off to 2 significant figures. So we would have just counted 1, 2. Again, remove a 1 from this 9, put on this 9 to become a 10. So you can't write a 10. So remove a 1 again, put on the 4, it becomes a 5. So it will still be 5, 0, 0, 0, 0. So in other words, this same number is 2 significant figures. It is 3 significant figures. It's actually also 1 significant figure. So depending on how they have asked you to round it off. Because there's nothing that you can do. It's a special case. We can't do anything. Okay? Hope that's okay. And how about if you've got 0.0001256? They say round off to 2 significant figures, this number. So 2 significant figures, this number is significant, this one is significant, so I'm removing from a 5. So I'm going to be removing from a 5, putting here. So this is going to become 0.00013. But please don't make these to become zeros. Why? If I put them as zeros, we are going to have 4 significant figures. But the question is, write it to 2 significant figures. So don't write those 2 zeros at the end, because they are going to be significant. Hope that makes sense. Does it? Okay, good. The last one you need to understand is the 5. When you have got, let's say, 2, 4, 5, 6, you want to round off to 2 significant figures, 1, 2. You can see you have got a 5 here. As long as you have got a 6, not just a 6, but as long as you have got a number other than 0 in front here, just remove a 1 from 5, put on 4, so it becomes 2, 5, and then those others become zeros. Says 2 significant figures. But if we had something like this, if we had said 2, 5, okay, let me put 2, 4, 5, 0, 0. They say round off this number to 2 significant figures. You are going to count 1, 2. Because this is a 5 and you have got zeros, so either if you have got zeros this side or you don't have a number, what will determine whether you are going to remove a 1 from a 5 is this number here. If it is an even numbers 2, 4, 6, 8, 10, don't remove a 1 from 5. So therefore this number to 2 significant figures is just going to be 24, 0, 0, 0. But if this was 2, 1, 5, 0, 0, you want to round to 2 significant figures, this will be 1, 2. And we are trying to remove a number from 5. It has got zeros. If there are zeros at the end or there is nothing, look at the number that comes before 5. So you are looking at this number. Is it an odd number or an even number? So 1 is an odd number. So since it's an odd number, you are going to remove a 1 from 5. So it becomes 2, 2, and then the rest will become zeros. If this was, let's say, 3, 8, 5, they say write this to 2 significant figures, 1, 2. We're supposed to remove a 1 from 5. But since there's nothing this side, look at the number that is here. This is an even number. So you are not going to remove a 1 from 5. So it's just going to be 3, 8, and a 0. If it was 3, 5, 5. You are removing a 1 from 5. Since 5 is an odd number, you are going to remove a 1 from the 5. So this becomes 3, 6, 0. We've rounded off to two significant figures. Does this make sense? Yes. Yes. As long, yes. And it's only for 5, all right? It's only for 5. And that's only if there are no numbers this side, or there are zeros after a 5. That's when now you start looking at the number that is in front. Only 5. But if it is a 5 and there is a number this side, this rule stops applying. You are going to round off whether it's even or not. Let's say, for example, you have got 2, 5, and then there's a 1. You want to round off to one significant figure. 1 is just this one. So it doesn't matter whether it is odd or even, just remove a 1 from 5. Why? Because we have got a number this side. But if it was either a 0 or there was nothing, that's when now you pay attention to this number that is here. If it is odd, remove a 1. If it is even, don't remove a 1. Does that make sense? Good. Is there any other question? Okay. So the last thing I should mention, and then we are done with units and measurements, is what we call accuracy and precision. Accuracy and precision. Now, if we say someone is accurate, it means they are to the point, right? To the point. Let's say, for example, you know those people that throw. If you've watched movies, they are throwing what? They are throwing knives to come and hit on the middle here, or maybe they are shooting so that the bullet can just reach there. If you shoot and then you reach exactly on this point, it means that you are accurate. That's the meaning of accuracy. Accuracy means that when you are performing a measurement, that measurement is very, very near to the true value. Let's say, for example, I'm doing a titration. I'm using a titration because that's at least it's something that we did in high school. And let's say the true titer volume that I'm supposed to use is 2 millimeters. But as I'm doing a titration, I can make some mistakes. So this is the true value here. And when you are doing a titration, you just don't use one value. You do the procedure a lot of times. Let's say, for example, we have got three people: person A, person B, person C. For person A, they measure 1.9 for the first time. Second time they measure 2.0. Third time they measure 1.9 again. The other time they measure 2.1. Person B, let's say they measure 3.0. Again they measure 3.1. They measure 3.0. They measure again, let's say 2.9. Person C, let's say, measures 1.9. They measure 3.0. They measure 4.1. Again they measure, let's say, 2.9. If you look at person A, these values 1.9, 2.1, 2.0, 1.9, 2.1, they are very close to the true value. So because all these numbers are close to this true value, actually the way you are going to see if they are close is add all of them and then divide by how many they are. You are finding the average. And then that answer that you get compared to the true value, that will give you the accuracy. So because these values are close to the actual value, it means that this person is accurate. And because these values, they are close to each other, not to the true value, but in comparison to themselves. So precision is how close repeated measurements are to themselves. 1.9, 2.0, 1.9, 2.1, they are very close to each other. So this person is both accurate and precise. If you look at person B, they have got 3.0, 3.1, 3.0, 2.9. These values are very close to themselves. It means that this person is precise. Why? Because the values are close to themselves. But then these values are not close to the true value. So this is not accurate. The person is precise but not accurate. They are inaccurate. If you look at person C, the values are not close to the actual value, neither are the values close to themselves. So this one is neither accurate nor precise. Okay, neither accurate nor precise. So what causes inaccuracy? What causes someone to be not precise? Let's say, for example, the instrument that this person, the burette that this person was using to do a titration, because the burette is supposed to start at 0. Let's say the instrument itself started at 2. So it means that whether it is me, an expert, or it is someone who is not an expert, or it is any person, as long as they are using this instrument, they are still going to get mistakes. So we call such mistakes as indeterminate errors. You So not indeterminate but determinant errors. Determinant errors. We also call them systemic errors. So determinant or systemic errors, these are errors that you can determine. You can actually find that, oh, the reason as to why we are all finding these values is because the instrument that we are using is not correct. So systemic or determinant, we call them determinant because you can determine them. These errors can be corrected. Okay, they can be corrected. But let's say, for example, another person is performing an experiment, and maybe because it is too hot, the weather affects the way you are measuring. So this one, the first person, they didn't get exactly 2, maybe because as they were opening the tap, you remember when you are doing a titration, you're supposed to be opening the tap. When they're opening that tap, they missed a bit, the volume, just a bit. So such mistakes, you can't avoid them. So we call them indeterminate. Indeterminate. You can't determine them. Indeterminate, or we call them random errors. Now, random errors are always part of an experiment. So these ones you can't correct them. They are part of us as human. We can't avoid making errors because it's part of us. And random errors are caused because of changes in environmental conditions and such. While systemic errors are caused by problems. Let's say, for example, the person that is using the instrument doesn't know how to use it. They are not trained, or maybe the instrument has got a problem that is going to cause a systemic error. So these errors, you can express them as a percentage, right? Let's say, for example, I have found a value. The values that I found, let's have found are found 1.9, but the true value is 2. So I can find the percentage error by simply getting the value that I found divided by the actual value. So there's what we call the absolute error, and there's also the random error. The relative error. Absolute error is simply what I have found, true value, and then I'll remove the recorded value. So this is the true value 2. The recorded value is 1.9. So if I subtract these two values, I'm going to find the absolute error. And then relative error is given by absolute error, and then you divide by the true value. Let's say, for example, if you subtract 2.2 minus 1.9, you are going to find 0.1. So 0.1 is the absolute error. Therefore, the relative error is going to be 0.1 divided by the true value, which is a 2. You can also find what we call the percentage error. Percentage error is just you getting the relative error, multiplying it by 100%. Okay? So these are the basics that you need to understand when it comes to units and measurements.